Okay, now we've talked about the law of sines, and we only use the law of sines when we have a non-right triangle. Okay, there are situations such as these two triangles. If I were to try to use the law of sines, I would have to set up, here's my angle measure. I could set up the sine of 59 degrees over x equals. Now, the problem with this is I don't have a second angle measure. Okay, and so I don't know. I know that the three angles add up to 180, but I don't know what the second one is. And since I don't know the second one, I can't figure out any of the angles. So the law of sines cannot be applied in this situation. We would have two variables in our proportion, and we can't solve that. So we have what's called the law of cosines. Now, the law of cosines is a much more difficult equation than the law of sines, so please don't get frustrated. Just give your best effort on doing this. This kind of explains how we arrive at the law of cosines, and it's derived from what we know about the Pythagorean theorem. Okay, and as you look at it, here's the formula for the law of cosines. It says c squared. Remember, c, when we use the Pythagorean theorem, was the hypotenuse. So that hypotenuse squared is equal to a squared plus b squared. Those are the two legs. And then it says minus 2 times a times b times the cosine of c. So it's a kind of a long formula. I don't need you to memorize it. I will give it to you on the quiz and on the test. But I do want you to be able to use it. This is where our algebra comes in. Okay, so we're going to use it in situations like you see up here where the law of sines cannot be applied. Okay, so let's look at those two triangles here. Okay, and the law of sines again is c squared equals, we're going to say a squared plus b squared minus 2 times a times b times the cosine of c. Okay, so in order to use this, okay, the angle measure that we're given here, we're going to use that as, we're going to call that our c value. Okay, that's going to be our c value, which means that the side that's across from c, angle c, this is going to be our lowercase c. We're going to use that like our hypotenuse. Okay, that's one thing that you have to make the decision on. So if you're given an angle, that angle is automatically c. Making the side across from it your c squared. So as I plug things in here, since c is x, it says x squared equals. Now these are a and b, and just like with the Pythagorean theorem, it doesn't matter which one's a and which one's b. Okay, they've used this as a, and they've used that as b in the formula. So they've got 24 squared plus 28 squared minus the 2, and then it's times a again, times b again, times the cosine of c. Now, once you have all those substituted, okay, get your substitution, and then you've got to solve this using PEMDAS. Okay, so PEMDAS says parentheses first. Well, parentheses are just showing multiplication in this case. There's nothing inside the parentheses to do. But then E for exponents. In PEMDAS, E comes next. So I'm going to evaluate my powers. So 24 to the second power is this 576. 28 to the second power is that 784. Okay, after exponents comes multiplication. So these are products. Okay, we're going to have to multiply 2 times 24 times 28. That's that 1,344. And we take it times the cosine of 59 degrees. And again, to find the cosine of 59 degrees, you're using your table here. Find 59 degrees, go over to the cosine, and you're getting this decimal. So we're going to do multiplication before we add or subtract. We multiply in PEMDAS. Okay, so I'm multiplying these together and I get 692. Now I can add 576 plus 784 and subtract 692. Get down to x squared equals 668. And we don't want x squared, we want just x, which is c in this case, the side c. Okay, so c is going to equal the square root of that. Last thing you do is take the square root because you want to get x by itself. So you take the square root of both sides and you get 25.8. Again, that is a side length, so we're rounding it to the nearest tenth. Okay, I'm going to move this second one up so you can see that a little bit better. Okay, again, we're using the law of sines, which says c squared equals a squared plus b squared minus 2 times a times b times the cosine of c. Now, sometimes we use this when it's the angle measure that we're trying to find. Whatever angle that you want to know, okay, whichever angle it is that you're finding, that angle has to be angle C. Even though it's labeled in the picture with a lowercase a, sometimes it'll be an x, but whatever angle you're trying to find is your C, which means the side across from it has to be side C. Okay, so I'm going to plug 25 in for my c squared. I'm going to put 25 squared equals, again, the other two sides you can interchange. It doesn't matter which one's A and which one's B. So they've got 19 as being A, and they've got the 27 as being B, minus 2 times A again, times B, times the cosine of C. Remember, they used the letter A to represent C. So now we're not finding the side length, but we're finding an angle measure, so we leave that like that. This is a little more difficult to solve. So again, we follow PEMDAS. PEMDAS says do what's inside parentheses first. Well, there's my parentheses, but there's nothing inside to do. So it's not really, parentheses aren't really there for that purpose. E in PEMDAS, that's exponents. So I'm evaluating the exponents next. Okay. M for multiplication or division, so these three values can get multiplied together, negative 2 times 19 times 27. Okay, now this is multiplication right here. So we are able to add the 361 and the 729 to get 1090, but we are not able to do that subtraction. The reason we can't subtract here is because this is a product, and so I have to know what that value is to be able to multiply before I can make that subtraction. So here's what we do. We don't subtract the 1090 and the 1026. We subtract the 1090 from both sides of the equation. Right here, we're going to subtract 1090. It's okay to get negative numbers. In fact, I expect that. I'm going to get a negative 465 equals a negative 1026. At this point, you divide by that 10,026, that negative 10,026. You're trying to isolate the cosine of A, or in this case, if you called it the cosine of C, that's fine. But you're trying to isolate that. Why? Because you want to use your inverse function. Again, this is an angle measure, so anytime we're finding the angle measure, you're going to put that decimal in, 0.4532, and you're going to use your inverse cosine. So I hit shift cosine, and when I round it, I get 63 degrees. Okay, so this is a much harder equation to use. Stay patient with it. We'll take our time in class working with it. Please join the Zooms, okay, and follow along. Try to have as much done as you can so that you can see what we're doing in class and you're kind of up to speed. Okay, give that worksheet a try.